In this experiment, we are going to study an acceleration of a body on an inclined plane. Our objectives are: the first objective is to measure the acceleration of the body A, which we call A. Second objective is to verify the relation A equal G sine theta. The third objective is to calculate the value of G, gravity acceleration. Now we will explain the theory of this experiment. This is an inclined plane. This angle equal theta. Here is the body. This the height h of the inclined plane. The gravity force equal mg. The force which causes the motion on the inclined plane is the component of mg in the direction of the plane, which equal to mg sine theta. Here the other component mg cosine theta. Here is the normal force. So the only force which causes the motion of the object on the inclined plane equal mg sine theta. If we apply Newton's second law, F equal ma, which will equal mg sine theta, we cancel m from the two sides. We'll get the relation A equal G sine theta, which we are going to verify in number 2. Now, if we plot the relation A and sine theta in a graph, here A, here sine theta, we'll get a straight line. We should get a straight line. If we find the slope of this straight line, or the gradient, this slope will be equal to G, which is the factor of the variable sine theta. This is the theory of the experiment. Now we are going to discuss the tools and the procedure of this experiment. The tool which we are going to use in this experiment is the dynamic track kit, which include the main part is the track itself, which is about 120 centimeter, and some accessories. We will use one of these accessories, which is the cart, which is supplied with a barrier which can fix to the track, which is about 8 centimeters. Also, we have two photogate sensors, which are connected to the computer or the tablets by a wire, USB wire, or maybe connect to a tablet or Android system by the Bluetooth. In this experiment, the two photogate sensors will measure the time of passing through the photogate. So the sensors will give us 3 times: T1, or the time of gate 1, and the time gate A, and the time of gate B, and the time between gate A and gate B, which we call TAB, time between A and B. This what we are going to measure. This data is given to the software, and we will use the software to analyze what we need. The first thing, we will build an expression for V1, which is the velocity of passing through gate A. We will divide the length of the barrier, 8 centimeters, on the time of gate A, the time of passing through gate A, to find V1. This called V1. Then we will build an expression for V2, which is the velocity of passing through gate B. We then built an expression to find the acceleration, which equal V2 minus VT1 divided by TAB. When we find the acceleration, we will calculate the sine of the angle of the inclined plane. We begin with a theta equal 0. The height of the two ends of the track, the dynamic track, equal 0. So the angle will equal 0. We will find the acceleration of the cart. It will be equal to 0. Then we will change the height of the track from one end, and the other end still as it. This height, we measure it by a meter. This is about 9 centimeters. We subtract the height of the other end of the track, which equal 3 centimeters. So the height of the inclined plane will be 6 centimeters. Then we change to the other height, which will be equal 10 centimeters. Then we add a block with a thickness of 3 centimeters. The height will be 13 centimeters. Then we take another height by adding another block. The height will be 16 centimeters. And for every height, we will let the cart to accelerate through the photo gates, and we will find the acceleration in every trial. Then we plot a relation between acceleration and sine theta. We can calculate sine theta by dividing the height of the inclined plane on the length of the track, which equal to 120 centimeter.